Are we at time? We are. I have to go now. So if you're missing this wonderful talk, well, then that is your problem. Okay. Who here watches football? 1, 2, 3, 4, 5-ish. Right, cool. I'm also and a half, right? So let's call it 6. But one thing I do love is data. So just for those of you who don't know, which is all of you because you've never met me before, I am a curriculum developer for Graph Academy. I'm going to chuck a QR code up at the end of this. If anybody wants to learn about Graph or learn how to avoid the mistakes I'm about to show you, ooh, suspense, then sign up. It will be free forever. Is anyone here from Spain or South America? No? Well, obviously you always have to pipe up, don't you? Jesus Christ. Oh, God. There you go. Yeah. Right, so I'm starting with this little quote. In a village in La Mancha, whose name I do not care to remember, an hidalgo lived not long ago, one of those who keeps a lance from the rock, an old leather shield, skinny nag, and swift greyhound. That's my Javier Bardem. Do with it what you will. So this is a quote from Don Quixote. It is the opening paragraph. Does anybody know who Don Quixote is? No? Yeah, ish. Okay, so Don Quixote is famous for tilting at windmills. He went on an epic quest in his own imagination, and this is his helper, Sancho. And he's generally a bumbling fool, but we love him because he's so naively enthusiastic about everything he's doing. So he's fighting a windmill because he thinks it's a dragon, okay? Sancho is his helper. So the question is, am I Don Quixote and Sancho is Claude? Or more likely, is Claude Don Quixote and I am Sancho? So here is the match between Morocco and France, which took place either yesterday or the day before. This is an event graph of every event that occurred in that match between the players. So each one of these is a player at that particular point in time. I'm not going to play the whole thing because it is 90 minutes. So even sped up. But here you go. You can go see this if you want to on globalchalice.com. So here you can see all the different events as a graph. And does anybody know anything about graph data science? Yes, you do. You're looking at me with eyes like you know exactly what graph data science is. Yes. Well, it's okay. It's okay. I'm giving the talk. No, all right. Right. So graph data science allows you to investigate and analyze your graphs with a bunch of different algorithms. So one of them you are all very familiar with. Question that you all have to answer yes to. Who has used Google? Yes. Awesome. Amazing. At least one of you. So Google, when they first became sort of the dominant search engine on the internet, they did it with a little algorithm called PageRank. There we go. This is PageRank. So you can take any kind of data model and you can apply algorithms across multiple domains, okay? It's actually all about the structure and the shape of the graph. It's not necessarily about the domain itself. So in this particular domain, we have players. This is called a monopartite graph. Now, if we take players and we substitute web pages and we substitute links with ball events passing from player to player, then we essentially have Google, right? So this is how they figure out who is the most influential. In this case, the most influential person on the pitch at this particular point in the game is Michael Olise, okay? Fantastic. So, do you know that the bookies don't use graph? Most of them don't anyway. But there's clearly got to be some predictive information in this graph. Surely we can see who's going to win. If we have all of this data for every single match in the history of football, we should be able to predict, at least as well as the bookies, who's going to win the World Cup. Yeah? Hands up if you think yeah. Hands up if you think no. Okay, awesome. And we've got a lot of ishes. You're Mr. Ish over here. I love it. Okay. So, as it happens, I do have all of the data for almost every football match ever played, including this World Cup. Don't ask me how I got it. I had to do some nefarious things. No, I didn't. So, we have two data providers. One of them is Impact, who are our friends. And one of them is StatsBomb, who are also very friendly. but they give you open data on football matches. So I have everything up to World Cup 22 from StatsBomb and everything up to World Cup 26 from Impact. Currently, if I show you this graph, is it here? I did not put it up here. Hang on. Whatcha? 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 Boom. Okay, this is my graph. I have 99 million nodes. I have 500 million relationships covering most matches. It may shock you to know that it's really hard to predict football because there isn't enough data. Each match only has a limited set of events, right? So this is a structure I want you to remember. This is how I've organized it. There is a player, right? And they have an event. And that event has an event that follows that event. And that event is also by a player, sometimes by the same player. We allow that. Okay, and here is the overall data model. Whatcha? That is a lot of data. How the hell do we do anything with this much data, with this many connections? So that's why I'm not going to show you this. I'm going to show you this. Okay. Here is one match from the Bundesliga. It is Leipzig v Leverkusen. Okay. Leipzig won 2 or lost 2-3. And we've got impact data over here. And we've got StatsBomb data over here. And we've got all the players over here. So you can see that these graphs are almost identical, yeah? So do we think it's the same match? Who reckons the data is the same across both providers on the same match? We've got Lufa over there, thinks yes. Okay, we're not sure, we're not sure. It is completely different. It's like they were watching 2 different matches. So here we have all of the properties from StatsBomb on that match. Okay? And here we have all of the properties from Impact on that match. There's almost no overlap. The only overlap is passing. So this is what's called a projection. I'm going to rush right past this, but you should go to graphacademy.com to learn what a projection is. This is the query that we run to project a subgraph into projection space so we can run algorithms on it. Boom. So this is the data model that I decided to project. So we have our StatsBomb event, we have our impact event, we have our player, and then we have event type. I've made a huge mistake here. And the reason I made this mistake, I actually know that this is a mistake. I've known that this is a mistake for a very long time. But I allowed Sancho or Don Quixote to trick me and lead me down a garden path, which you're about to see in a moment. Does anybody know why this is a mistake? No? Okay, you're about to find out. So, whatcha? This is the data model that we are projecting, okay? It's actually not the whole thing. This is only 4,159 nodes. The actual data that I projected was in the range of about 5.5 million nodes. Now, on this data, we can run things like PageRank, which we just saw. But remember, this isn't one match. This is one player's entire career, over time, over history, and they're all interconnected. So if you have a career in Leipzig and I have a career in Shamrock Rovers, we'll never meet because Irish people suck at football. But, you know, maybe someday we can all dream. So if we played together, we would be connected directly in this graph because I lost the ball to you on an interception, okay? So we can run these, but does anybody notice anything strange happening here? Let me show you with this one. K-core decomposition is an algorithm that gradually takes the least connected node out of a graph, one by one, to find the most connected clusters of nodes, okay? And notice that we've got impact up here, which is our first data provider, and we've got StatsBomb down here, which is our other data provider. So we can see that the most connected is actually StatsBomb. The reason for that is StatsBomb has more granularity to their properties, yeah? Which means that this data is way more connected. So what I've made a mistake here with the data model, but I didn't actually make this mistake because what I actually did was this. So I collapse the entire thing into a player model, as we saw in the football match at the very, very beginning. Now, if I run these, they make a lot more sense, right? So let's run K-core again. So now we can see which players are actually most in the most connected groups. We can run PageRank. That's our Google one. So Google says that this player is the most connected. Fantastic. Is the most influential, rather. So what we can do now is we can take all of these features, because these will all get computed as numbers. Each one will get a PageRank score, will be put into a Louvain community, eigenvector, blah, blah, blah. I'm not going to go into each of them. I'm also computing something called embeddings. Does anybody know what vectors are? Embeddings? Yeah, hands up. Yeah, sweet. Okay, who thinks that they always have to be something to do with words and meaning? Good. So we can also embed graphs, graph structure. So that's what I'm doing here. So I'm seeing where this node is in the network compared to others, and I'm encoding that as a vector. Fantastic. Sounds great, right? We're getting so much information here. It's just perfect. So now if I reproject that, okay, now I've got this huge graph, and all my individual players, it's all I care about. They've all got their features on them, so I know what their fast RP network is in relation to each other. I know how influential they are over time. Okay, fantastic. And now I'm going to train something called GraphSage, which is another embedding model. It's a machine learning model that will learn the properties. You can use it on something called heterogeneous graphs. That's a big word. Say it with me, heterogeneous graphs. Yeah? Okay, no worries. So we're going to train GraphSage, and it's basically doing the same thing as FastRP was doing, but now it's including all of the properties, all of the labels, okay? And it's encoding them. Fantastic. Amazing. I'm so smart. So we've just done this in 4 steps. I know it seemed like a million steps, because it actually was, and I'm pretending that it was 4 steps. Awesome. So now, here's the entirety of World Cup 22. So let's test it. We have a World Cup that's already passed. Is this predictive of the World Cup? And let's do this. Look, ooh, one shot. We love that. One shot embed. So I'm going to take my graph model, my graph embedding model. I'm just going to chuck StatsBomb in there, and I'm going to go, whoopah! Boom. All my players are embedded. Amazing. So now I'm going to use an algorithm called k-means, which is going to take all the players that are within the top k15 of each other in terms of similarity and put them into a group together. Cool. So now all my players are in these groups, okay? And I can see which players play most similarly to other players. Now remember, I've made a mistake here. So what we're going to do is we're going to take every single player who ever played a match. We're going to match them up with who they play against. So strikers against goalkeepers, midfielders against defenders, blah, 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 blah. Okay? And if we click them, now these are our groups. So we say, okay, this player was on a team that lost against a player that had this team. But who do we care about? Russo v Landaluce. Okay? So now we can say Ballesteros. If Ballesteros goes against Rep, whoever the hell that is, then they play very similarly, so they may have a similar outcome. But we're not just using their outcome, we're using the aggregation of their entire cluster outcome, okay? Sounds like it makes sense, right? Yeah. To be fair, that bit does make sense. So, beautiful. Does it predict the World Cup 22? No, it doesn't. Actually, it's slightly worse than a coin flip. But why? Because I made a terrible, terrible error. I made 2 terrible errors. The first error was, in fact, no, that was the second error. The first error was I discovered Claude Remote Control. So I hooked up to my IDE through Claude Remote Control, and I was just messaging Claude. I was like, yeah, Claude, you know what to do. Just run GraphSage, encode the properties. Yeah, sweet, sweet. Cool, bro, whatever. And Claude was like, yeah, I've got that. Oh, wait, hang on. Maybe I don't know what the user means. Okay, cool. Yeah, no, I've definitely got that. Yeah, everything's cool. I just need to make this look like it works for the user, and then they'll say cool, and everything will be great, and then they'll burn more tokens. So the problem was the event node, event type. There's a thing in graphs called supernodes, okay? And this, if I can hit one thing home to you right now, for any of you embarking on your graph experience, data modeling is the most boring, but the most important part of graph. If your data model does not represent the data or the question that you're trying to answer, then your graph algorithms are going to run. You're going to get some super cool numbers. You're going to be like, yo, boss, I just ran these cool algorithms. You've no idea what they mean. You've no idea what this says. But here's some numbers. Haha, business, yes, good. Run more algorithms. But you won't be producing anything useful. So what did GraphSage do to this graph? It created a cone. Can anyone guess what these represent? Come on, hands up, one of you. Boom, yes. What it did was it embedded, it trained and learned that we have two data sources. That we have one data source from StatsBomb and we have one data source from Impact. Isn't that fantastic? So that was like 30 hours of compute, a bunch of headache, a bunch of like debugging, trying to work stuff out. And I was like, yeah, cool, sweet. I don't know if you know this, Henry, but we've got two data sources in this graph. So this is what I should have done. And this is actually a lesson I learned many moons ago. If you check out my Medium, you'll see what I mean, but I'm not going to go into that now. You don't have to make a vector you can make a vector out of anything. It doesn't have to be an embedding model. It doesn't have to be machine learning even. You can just make a vector that represents the features of anything. So I ask you to remember this. This is our player event model. Player, by player, event, next event, by player, boom. So now let's collapse this into our monopartite graph. Oh, isn't this lovely? This is another thing. I'm trying to encode in the previous version the entire event, next event in time series. I don't need to do that. I can just aggregate every event that they ever had. See if there's any signal in it. I mean, you can do that. It's not wrong, but so now we've got this graph and all those beautiful things that we computed. Look at them. They're all here, ready to go into a big array that's a vector, and they'll all be comparable from one provider, not from two providers, not from multiple data sources, right, that haven't been merged, one provider. And this is what it looks like. Isn't it beautiful? So now we can run Leiden. Leiden is a community detection algorithm. It will find natural communities inside your data and cluster them together. Right? So instead of me arbitrarily deciding there should be 20 players that are similar, and I don't care about all these other players that are identical to this player according to the data, I want them to be 20. I can actually find out which players are genuinely similar within a threshold. And now we go back to our graph. And boom, so we get exactly the same idea. We get the win-loss aggregation over all the matches of a player's entire history. And now, does it predict World Cup 22? Yes, so the bookies, with all of their machine learning models, with all of their data collection, with all of their like live data, et cetera, in any case, any match where it wasn't a draw, they were right 69.4% of the time for World Cup 22, and we are right 65.3% of the time. Now, I do have to say, this is a lie. It's not a lie. It is real. The results are real. And I'll give you the code at the end. But I also tried it out on held out club matches, 257 of them, and we got 57.2%, which is still signal, okay? The problem with this is that we've only got like 80 something matches. So it's very low. So some of that is noise, right? So, but what about World Cup 2026? This is the one we care about, right? Well, we also got 64% on the matches already played. And so here is the prediction for the matches that have not yet been played. England, I'm very sorry. You are possibly going to lose to Switzerland. Switzerland is going to beat Argentina. And France is going to win overall against Switzerland. We will see. Maybe, maybe not. There's a 64% chance that I'm right. So I've been Henry Collie. Thank you so much for listening so patiently. If you have any questions, come back to me. However, what I would love for you all to do, we provide free education and hopefully free education forever to developers just like you. I'm a curriculum developer. Martin is a curriculum developer as well at Graph Academy. We would love it if you came on, enrolled, learned some stuff, because it validates what we're doing and it allows us to give you more free education over time. We love developers and we hope you love us back. Thank you.